Okay, so we already saw that light is made up of like an infinite array of wavelengths. Okay, so I'm going to show us how we know what molecules or elements can be found in a star. So here's light, and it's made up of all possible wavelengths. Right, so there we go. Put a little one here because they're not ordered. And this light is coming from over there, and here is an atom. I'll make it a fairly simple atom, a hydrogen atom. Doesn't really matter. But according to quantum mechanics, this is a model, right? It's not what an atom actually looks like, as far as we know. But according to quantum mechanics, the electrons exist in shells around the positive nucleus. So let's put an electron right here. Now, it can't exist anywhere except for in one of these shells. And each of these shells has a certain energy. So let's call this E1 for energy, and level 2, E2 for energy. Now, it is, if enough light is coming in here, we're going to get light which has a wavelength. We call light a gamma, or a photon. So the wavelength of this light is exactly right to cause this electron to jump up to here. And now we see that this atom is in an excited state. So what it's done is it's absorbed the energy of this photon and used it to jump up to here. But the energy of the photon has to be exactly the same as the energy difference between these two levels. So the energy of our photon is exactly equal to E2 minus E1. So let's see what happens now to our light that's coming through. Actually, I'm going to erase this because it's in the way of the light. So this one comes through. Let's say this is the one that got zapped, right? It got absorbed by this electron. This one comes through, this one comes through, this one comes through, and this one comes through. So everything comes through except for this exact wavelength, right? So then what happens to our spectrum? So this is our continuous spectrum. We have all the colors except for this particular wavelength right here. So let's, the energy is proportional to 1 over the wavelength. So the bigger the wavelength, the smaller the energy, or the shorter the wavelength, the bigger the energy. So this exact wavelength is missing. And this is what we call an absorption spectrum. But from this we can see exactly what molecule or atom had to be there. And we can also tell actually what temperature it had to be at, because this will vary slightly according to the temperature. Like it's possible that the electrons could make a different jump. It's possible that the some particular atom may be ionized, which means the temperature would have had to be very high in the first place. So we can tell a lot from this spectrum.